Hi, I'm Justin from Hydrophase, and today we're going to be installing the Ridesteady GPS speed control on this 1999 Super Air Nautique 210. We're going to be going through all the steps in the installation manual, including installing the throttle, motor, and control cable to the engine, installing the 3.5-inch display into the dash, connecting the RPM cable to the tachometer behind the dash, of course installing the GPS, and we're going to put it on top of the dash, installing the air and water temperature sensors, and of course installing the Ridesteady CPU.
For the throttle motor, the key is to find a location that you can mount it where the control cable will have a smooth bend to where it connects to the throttle arm on the engine. Often the throttle motor can be mounted on the exhaust hose connected to the riser. On this engine, the best location where there were no clearance issues with other parts and allowed a smooth bend in the control cable was on the riser itself. The throttle motor can be mounted in any orientation and is heat tolerant, so mounting to the riser was easily accomplished. A pair of large hose clamps, available at any auto parts store, were daisy chained together in order to secure the throttle motor to the riser. The old speed control is now removed from the throttle arm. Most engines will not have old speed control, so the throttle cable would be disconnected from the throttle arm instead. Here we can see the control cable in loose preliminary positioning. The throttle motor is mounted to the riser, the control cable has a smooth bend, and the cable guide is secured to a hole in the existing throttle cable mounting bracket. A flat bracket attaches the control cable to the existing throttle cable. An L bracket attaches the control cable's inner stainless steel cable to the throttle arm. The fasteners are loose now in order to determine the best positioning that allows for the most natural throttle cable movement. Once everything looks good, we'll tighten everything up. In this instance, the throttle cable naturally wants to go in about a 45-degree angle for the least resistance, so that's what we'll use as we tighten it. Here is another close-up view that shows better the cable guide installed into the existing throttle cable mounting bracket hole. A few requirements are important to keep in mind as the control cable alignment is adjusted. First, with the driver's throttle lever in neutral, there should be no gap between the threaded stud on the inner stainless steel cable and the outer sheath of the control cable. Second, all the fasteners on the cable guide, control cable, and throttle cable should be tool tightened with the exception of the L bracket. The bolt connecting the L bracket to the throttle arm should be tightened fully but then untightened 1/2 to 1 turn in order for the L bracket to swivel freely. This allows the control cable to follow the arc of the throttle arm as it moves during operation. Here is a look at the finalized setup. The throttle motor is attached to the riser, the throttle motor electrical cable is connected to the throttle motor, and all of the connections have been tightened with the exception of the L bracket connection to the throttle arm as previously discussed. To demonstrate how it works, when the speed control is off, you'll have manual throttle control. So when you push the throttle lever forward, it will open just as normal, and when you pull back, it will close, just like you had before without any speed control. But when the speed control is active, when you push the throttle lever forward to open it, the throttle motor will let out cable like this and control the speed this way. This is called throttle reduction method, which only allows the speed control to go as fast as the amount of gas you give it.
We're going to be replacing the right speedometer, and in order to do that we need to gain access to the back of this dash. So typically they're just screws that you'll need to undo, and the dash pod will move forward. That way we can take the screws off and remove the existing display, put the Ridesteady display in, and then install the screws from behind. This will also let us gain access to the tachometer, where we will connect the RPM sensor.
The existing speedometer has been removed, and the pitot tube has been folded and clamped off to prevent water from coming in. The Ridesteady control panel is now installed into the dash. The RPM sensor wire is now installed onto the tachometer. It is attached to the same mounting post as the gray tach wire coming from the ignition coil on the engine. The power cable has 4 wires that need to be connected: ground, constant 12 volts, switched 12 volts, and navigation lights 12 volts. In this example, we're going to use the tachometer's switched 12 volts, which is a purple wire, ground, which is a black wire, and navigation lights, which on this boat is a blue wire. For the constant 12 volts, we'll use the B connection on the ignition switch, which is typically a red wire. Although we're able to connect the wire's ring terminals directly to mounting posts, if this is not available on your boat, the included Scotch lock connectors may be used to tap into wires. Directions are included in the installation manual on how to do this. The best location to mount the GPS receiver is typically under a non-metallic tinted windshield. The wire can often be routed under the dash pod, as shown here.
So now we're going to be mounting the water temperature sensor. And the water temperature sensor comes with the connector unpopulated, as you can see, it's just pins. And this allows us to either route the wire through the transom, through an existing pitot tube hole, from a broken pitot tube or one that you're not going to use anymore, or you can drill a small 3/16 inch hole and route it that way. Now that we've routed the wire through the transom, we're simply going to take off the backing of the VHB tape and stick it down, and then replace the cover, the original cover for the pitot tube.
The air temperature sensor is simply mounted so that a few inches hang in a cool, shaded area under the dash. This allows the sensor to be influenced primarily by the ambient temperature and thus give an accurate reading. The CPU is mounted in a dry location under the dash. It should be mounted upright with the connectors facing down to avoid drops of condensation from following the wires down into the CPU. It may be screwed into the fiberglass, as shown here, or it may be zip tied at any convenient location. It is important to note that the throttle motor power cable, the second cable on the left, must not be bundled with any other cables except for the power cable. It can often carry high levels of interference from the ignition system, and care should be taken to route this wire away from spark plug wires and other ignition system components as much as possible. After we have inspected everything and ensured that the fasteners are all tight and have completed the throttle connection test described in the installation manual, we are now ready for an on-the-water test. The test completed here was run with default settings with a set speed of 22.5 miles per hour. Please excuse the wind noise and reflections on the control panel. You may be wondering why a black-faced display was installed onto a boat with white gauges. This video was taken before white-faced displays were available. Here is a look at a similar Nautique with all white gauges installed. Thanks for watching this install on a Super Air Nautique. If you're ready to start enjoying time behind your boat, making every driver a steady speed driver, just email or call us. Most customers install Ridesteady on their own, but we're happy to work with service departments as well. Once you have it installed, you'll never know how you lived without the precision and responsiveness of Ridesteady speed control.